Okay, so what we're going to do now is emphasize a different part of limits. Limits, we said, look, try to plug it in. Hopefully you can plug it in, and we know what types of functions we can plug them in for, which would be polynomial functions. We know different rules about plugging it in, but sometimes plugging it in doesn't work, and sometimes when you plug it in and it doesn't work, you have to find different tricks. Now we're going to emphasize another part of the definition of a limit, and that's that the limit in the left, from the left, has to agree from the limit with the right. So the left and the right have to agree. For instance, if from the left my y value is 2, and from the right my y value is 4, those two numbers don't agree, so the limit doesn't exist. So we need from the left to be 2 and from the right to be 2. Then the answer would be the limit is 2. So what we really want to do is concentrate what's the limit from the left and what's the limit from the right. And those are called one-sided limits. So anytime I want to talk about a limit from the left, it's going to be the limit as x approaches some number, and then as an exponent, like in the exponent area, they're going to put a little negative sign there. And that negative sign here indicates, let me circle it on here, that negative sign means you're coming from the left side of that number. If on that C, if that's like a number 2 with a positive where the exponent goes, that number right there, anytime it's a positive, means you're coming from the right of that number. So one-sided limits, they're not asking what's the limit at that point, they're asking what's the limit on one side of that point. Here's a great example here, example 10. It says, find the limit as x approaches 0 from the left, is how you'd read that, with that little negative sign of f of x. And the limit as x approaches 0 with the positive sign, that's from the right of f of x. For f of x equals the absolute value of 2x over x. Well, we could get into this again and we could talk about, okay, well, this is an absolute value function, and when it's positive or 0, it returns the exact same value, and when it's negative, it returns the opposite value, and we could make it into a piecewise function, simplify it and see what it is, or we could just look at the dang graph that they already provided us. Much easier that way. So let's look at it. The point in question is, what's happening when x equals 0? Well, what's happening when we come from the left? I'm going to go ahead and highlight this here. From the left, here I'm coming in from the left. What's my y value every single time? Well, it seems that my y value every single time is 2. So that would be saying the limit as x approaches 0. Remember, my x value is approaching 0 from the left of this function is, sorry, that's not a 2, that's a negative 2. Is negative 2. Now let me look from the right. As I come in from the right, notice where I'm approaching. Well, I'm the same value every single time. My y value in this case is being 2. So what could I say here? I'd say the limit as x approaches 0 from the right of this function is positive 2. So what's the limit as x approaches 0 of this function? Well, notice they don't agree. And if these two numbers don't agree, not the same, then we could say the limit as x approaches 0 of this function does not exist. Because they're not the same, it doesn't exist. The limit from the left exists and it's negative 2. The limit from the right exists and it's positive 2. The limit at the point does not exist because they don't agree, and it's done. And that's what the next one says, the existence of a limit. It says, if f is a function and c and l are real numbers, then the limit as x approaches c of f of x equals L, so you're saying the limit exists, if and only if both the left and the right are equal to L. So we would say like the limit is 5. My y value approaches 5, right? If and only if it approaches 5 from the left and 5 from the right. That's what the next one is. That is to say, the limit as x approaches c of f of x equals L if and only if the limit as x approaches c from the left of f of x equals L and the limit as x approaches c of f of x equals L. So that's your one-sided limits.